Sometimes with quadratic equations, you'll need to find the vertex. To find the vertex of a quadratic equation, you're going to need to write it in vertex form. Vertex form looks like y equals a times the quantity x minus h squared plus k. Once you have the equation written in vertex form, the vertex is hk. In order to take an equation like y equals x squared plus 16x plus 20, you'll need to complete the square. One way to complete the square is by using an area model. An area model like this can be used, and because we know that our equation needs to have a perfect square part of it, like we see here, we know that the two sides of the area model here and here have to be equal in order for it to be a perfect square. So what we need to do is to start filling in the pieces that we know. We know that the x squared is going to go in this box here. And the way that we make an x squared is by multiplying x times x. Now the next thing is we need to take our 16x and we have to split it equally into the two boxes that you see here and here. Because again, it needs to be a perfect square. So the way that we can take the 16 and split it into two equal boxes is we have to divide it by 2, and that gives us 8. So that means this side is going to be plus 8, and this side is going to be plus 8. So now our area diagram is a perfect square. So completing the smaller squares in the area diagram, we take the value of 8 and multiply it by x, and we get 8x. To get the bottom left square, we're going to take the length, which is 8, and multiply it by x, so we get 8x. And just double checking, we want to make sure that these two are going to add up and give us the middle term. So if we take the 8x plus 8x, we are in fact going to get 16x. So those two boxes are completed correctly. Now we have to fill in the area of the bottom right-hand square. To get the bottom right-hand square, we're going to multiply our 8 by 8. 8 times 8 is 64. Now, 64 is not what we were supposed to get up here in our equation. We were supposed to get 20. So we have to figure out what we need to do to 64 in order to get it to the original 20. You may notice that a quick way to go from 64 to 20 would be to subtract 44. And sure enough, 64 minus 44 is equal to 20. So now that we have our area diagram complete, we can write our equation in vertex form. So our area model, because the two sides are equal, we can write it as a perfect square. So our two sides to start with are x plus 8 by x plus 8. And we also have this minus 44. But as I said, since the two binomials are equal, or the side lengths are equal, we can write it as a perfect square. So now it can be written as x plus 8 squared minus 44. So now our equation is written in vertex form. So if we use the information that we looked at earlier, and remember that the vertex in vertex form is hk, I can see my equation has an h value not of 8, but of negative 8. And the reason for that is because our general vertex form right here has a minus. So we have to think about this as if we were subtracting a value from x. So if we were to subtract a value from x, the value we would subtract to make it into plus 8 would be a minus 8. And so now we can see what the h or x coordinate of the vertex is. So then we subtract the 44 that we had up here by the area model to make it equal to 20. And now we can see our vertex form and then identify the vertex. The vertex for this equation then would be -8, -44. So when we write it as an ordered pair, we get -8, -44. And that's how you find the vertex when you're given an equation in standard form.